Hi, and welcome to the first video of Section 3, ggplot2. In this section, we begin by looking at traditional plotting, before moving to interactive visualization, with Plotly, and maps with Leaflet, ending with interactive charts using Google Viz. There are 6 videos in this section. We begin with ggplot2, where we look at the leading visualization tool to see what we can do. Then, in Plotly, we show how we can make our plots interactive. In Leaflet, we begin with ggmap to plot maps, before moving on to Leaflet to produce interactive maps to bring them to life. Finally, we have 3 videos looking at Google Viz, the interface between R and Google Charts API, letting us produce interactive charts. Here we're at the first video of the section. In this video, we'll work with the leading visualization package, color as another dimension, as well as facets. Quakes is one of the included datasets within R, so we have things to play around with. It's a collection of earthquakes with the longitude, latitude, magnitude, and other pieces of information. And we just plot that, the location, longitude, and latitude for each earthquake. So this is just a plot of the dataset, which is the kind of plot that I was familiar with from school. ggplot is one of the leading packages on R. We need to install ggplot2 in order to use it. So we can go to install ggplot2 and install it that way. Though I already have it. Tick that box to load it up. Then I can use ggplot. So here's a histogram of the earthquakes. So I can see most of them are at about magnitude of 4.5. Then it just falls down to 4, maybe 5. So that's a pretty standard plot. Nothing unusual about it. We can also do something like this. So here, again I've plotted the location. I've got the longitude and latitude. But I've set the color depending on the magnitude. Here we've got ggplot quakes, which is the dataset. We have x is equal to the latitude, y the longitude, and the color is the magnitude. So this gives us a far richer presentation of the data. Interesting. If we type in geom underscore, we can see there's a vast range of plots available. Density plots, histograms, line plots, maps, polygons, quantiles, text, box plots, and on and on and on. Which is what makes ggplot so good. This is a plot of empty cars. That's another dataset that comes included with R, and it's about cars and various pieces of information about different models. Similar to what we did before. We just have a plot where x is the weight of the car, y is the miles per gallon. So that would be our traditional plot. Next, we can use color. So again, we've got the weight, the miles per gallon, but depending on whether the car is manual transmission or automatic, we give it a different color. And from this, we can see that the automatic cars seem to be heavier, since they're on the right-hand side, on the bottom right-hand side, and they seem to have lower miles per gallon. Though not surprisingly so. Basically, the difference seems to be related to the weight. So in order for the car to become automatic transmission, we need to add more equipment, and that increases the weight of the car, and that lowers the miles per gallon. We can see that just from the plot, and it's nicely represented because we're able to use color. Next, we use facets. So you can see the command here. We've got empty cars, so that's our dataset. We've set x equal to the weight, y equal to miles per gallon, color is equal to whether it's automatic or manual. I've also size here, just because I can. So I set size equal to the number of cylinders of the car. We can see that, so the smaller dot, if it's a 4-cylinder, 5, 6, 7, 8. As I said, I just wanted to show that we can do that. I don't think this particularly improves the picture or adds insight. the main thing I wanted to look at here was facets. So with facets, I can say tilde gear. And that means that I want ggplot to make identical plots, only changing the number of gears. So this is the cars which have 3 gears, miles per gallon from just below 10 up to 35, weight from just below 2 to just above 5. So this is a plot just about cars with 3 gears. This is a plot just about cars with 4 gears. The interesting thing here is that both of these plots, in fact all 3 of these plots, have exactly the same scale, same coordinates. They all go up to 35, they all start at 10 for the miles per gallon, and the weight is the same range as well. So we can look across the different plots to compare them. There's no variation, distortion, or new bias added by having different scales. So we can compare the cars and see the impact that the gears has. Same data set, our empty cars. We have the X and Y coordinate. That's the miles per gallon. That's the weight. And we can see that as the weight of the car increases, its miles per gallon gets worse. But what we've added here is a geom smooth command. So there I'm just telling it to fit a linear model to the data and plot that as well. This produces the new blue line, the best line fit. One of our standout features is visualization. What we want to talk about in this section is its ability to do interactive visualization. Though first, we wanted to see what kind of visualization we could do, and then be able to see how things are different. In this video, we saw we could plot multidimensional datasets using ggplot, mapping to not only location, but also color, size, and more, providing far greater flexibility.